All right, everybody, here we go. What I'm going to do in this video is we're going to run down the solutions for the team test, and in each problem I'm going to tell you whether or not it's going to be on the solo test, so you want to make sure you listen to that, and whether it's just going to be more or less the same or if there's going to be any little differences. So we'll run through the whole test that way, and then there'll be a couple of other things that I'll throw on at the end, okay? All right, so here we go. So yes, there will be questions just like this on the solo test where you're given a couple of quadratic functions in standard form, and I ask you to write it in vertex form. And I'm going to ask you, as well as doing that, tell me what the coordinates of the vertex are, and tell me what the range of the function is. I'm going to add one thing to this. Instead of doing the domain, because everybody's kind of got that figured out, instead of doing the domain, I'm going to ask you to find the X-Intercepts if they exist for these parabolas. Okay, so we'll kind of add that into this discussion in this video. So anyway, here's one where A is some other number besides 1. That's considered more difficult. So because what you have to do is you have to factor that out. Factor it out of both of the x terms, kind of leave your constant alone, sort of out of this little factoring business. And so then our negative 18x, when you factor out negative 3, becomes positive 6x. And so this is the number then that you use to do the completing the square thing. In other words, take half of that and square it, so that gives you 9. And we've got our constant outside of this, this group here, so that's sitting there. Now, when we've added 9 here, what we've actually done is really deceptive. We've actually added negative 27, because this 9 that we added here is being multiplied by that negative 3. So the negative 3 times 9 is negative 27. To compensate for adding negative 27, we add positive 27. So that's where the positive 27 came from. It's just trying to keep the equation completely balanced and unchanged in its original state. We're just rewriting it in a different form, but it's the same equation. So 16 and 27 give us 43. This factors down to x plus 3, and so our vertex is negative 3, positive 43. There's our x coordinate of the vertex there, and there's a y coordinate. So there's the coordinates of the vertex. Domain is all real numbers, and the range is everything below and up to including 43. That's because this parabola is upside down, and it has a maximum point of the y coordinate of the vertex there, 43. So that's the range. This one over here, a little bit easier because a equals 1. So you just take your constant and kind of put it over here. Your negative 12 then, that's the number that you use to complete the square. So half of that is 6. 6 squared is 36. So we added 36. That means we subtract 36, okay? Because it's not being multiplied by anything. So it's just we added positive 36, then we add negative 36. And that factors down to x minus 6 squared, and then this gives us minus 15. So our vertex is at 6, negative 15. There's vertex form, there's our vertex, and this is a positive parabola, so this minimum y coordinate there of negative 15, that's where the range starts, and it goes up to infinity. So I thought we would just find the x-intercept of that first one, and one of the things that I was trying to show today is that it doesn't matter which form of the equation you use to find the x-intercept. All you have to do is replace y with a 0 and solve it for x. So you know how to do that here. You know what, I'm just going to erase it. Put a 0 there. And now we solve for x, and this is going to, since this doesn't really factor, your only hope really, not hope, but maybe the method that you want to use is to just use the quadratic formula. So you got, there's your negative b plus or minus the square root of 18 squared minus 4 times negative 3 times 16. All of that number crunching going on there over 2 times negative 3, so negative 6. And you just work this out and you get your x-intercepts. I don't even know what they are, but you can figure them out. It's just working through this number crunching here. You could, if you wanted to, since you've gone to the trouble of putting it into vertex form for these problems already, you could use vertex form to find the x-intercepts. Let's just show you that because it's kind of sweet how that saves you some number crunching difficulties, perhaps. If you just solve this equation for x by, let's say we're going to subtract 43 from both sides, and so we got this, right, negative 3 times x plus 3 squared. Then I divide by negative 3. Okay, so that's 43 over 3, and that just equals x plus 3 quantity squared. So if you think about doing those two steps, that's pretty basic. And then if you just take the square root of both sides, we're going to have x by itself pretty quick. So taking the square root of both sides here, plus minus the square root of 43 over 3, all right, whatever that is, that equals x plus 3. And I subtract 3, and we're basically done. Negative 3 plus or minus the square root of this kind of awkward looking fraction, 43 thirds. That equals x. There's my two x-intercepts, negative 3 plus that number and negative 3 minus that number. Good enough right here. That's it. You'll get that same basic number from using the quadratic formula here. It might not look exactly the same. In fact, I'm pretty sure it won't. But it actually will be the same thing if you do all the numbers correctly. All right? So either form works fine for finding the x-intercepts. You might consider this one using the Vertex form if you haven't tried that before. You could try it on the other problem, work it out on this problem here. Put a 0 in there for y on that one and solve it for x. You'll see it's pretty easy to do. All right, so that problem will be on the solo test tomorrow. Here's your solutions for number 2. This will not be on the solo test tomorrow, but absolute value function, there we go. Right-hand slope of negative 3, that's where a comes in right there. Shifted to the left 8 units, so x plus 8, and up 3, so plus 3 outside of the absolute value expression. The quadratic function's vertex form, really identical structure. Instead of parentheses and a square, it's absolute value bars. Same thing though, there's your stretch factor, your horizontal shift, and your vertical shift. Okay, this one's gone to the right 7 units and down 2. All right, so, but like I say, that won't be on the solo test. This one will though, and I'm going to give you a couple of problems where you're going to solve a system of equations. This looks like a lot of work. The problems that you're going to see on the solo test will have nicer answers, I promise. Okay, but these were kind of gnarly, setting this equation equal to this one. I chose to take y by itself here, 3x minus 4, and then set that in place of y in the quadratic. That's how I did it. Some people replaced this y with all of this, and you can do it that way too. It's tricky subtracting all of this stuff though. You got to be very mindful of what you're doing. So setting up a little, places to make more mistakes there, doing it that way, as opposed to this way. This way is pretty straightforward. Square the binomial, you get this. You still got the plus 1. I move over this 3x, so now it's negative 3x, and I move over this negative 4, so it's positive 4 over here. All of this combines to this quadratic, which I solved with the quadratic formula to give me this. These are my two x values, about 5.3 and about 1.7-ish, 1.697. I'm going to put both of those numbers into the equation. I'm putting it into this linear equation up here just because that's easier. And so replacing x with 5.3 gives me that number, and replacing it with that gives me that number. So here's make sure you pair up your solutions. This x gave me that y. This x gave me that y. So those are the ordered pairs for the solutions to that system of equations. Okay? Make sure you match up your x and y together when you express your solutions. This one happened the same exact way, really. We got a little bit nicer result because the quadratic that we got from setting these equal to each other, you can follow my steps there, is factorable, and we got x equals 3/2 or x equals 3, and those are two pretty easy numbers to put back into this linear function. And so we got 3/2 3/2 is one solution, and we got 3 0 as the other solution. Okay, so that will be on the test tomorrow, and I think in my opinion the problems that you're going to see are easier than these, but I'm not sure whether you will agree with that. I just don't know. We're going to flip this over. Some inequalities are going to show up on the test tomorrow, so yes, you will see some quadratic inequalities. Everybody got this one right. I'm not even going to talk about it. The quadratic inequalities will be more like C rather than B, but there will be 2 of them. But the important thing is, even if you have it set up this way, the first step really should be to set it to 0. It clarifies what you're doing. Rather than having numbers less than some other number, it's really nice to have compared to 0, because then things are just positive or negative. And it just clarifies what you're doing when you have 0 by itself on one side. So this one doesn't factor. I can use the quadratic formula. So these are two numbers, remember. So an x turns out, so I've got, when I'd say 3 minus root 5 over 2, that's about 0.38. 3 plus root 5 over 2 is about 2.6. And I'm looking for the numbers that make this true. It turns out because it's positive, it's a parabola opens up like this around through those two numbers. And so less than 0 is the place where it's below or it's in between these two numbers, okay? So that's my solution then, using these numbers in an inequality statement like this. This one over here, same kind of idea. This one factors, so that's easier. I'm asking, where is this greater than 0? Again, I get my two boundary points of -2 and +9. And if I test numbers in between though, like we've been doing, you'll find that numbers in between those give you a negative result, and numbers on the outsides give you positive results. So our solution, since it's supposed to be greater than 0, is x less than -2 and x greater than 9. You can also kind of verify that by imagining the parabola going through there, and the parabola is above the x-axis to the right and to the left of those numbers, and it's below the x-axis in between them. So the picture is kind of illustrating our solution as well. Okay, on the transformations problem here, yeah, you're going to see, and this may be a little confusing to you because I've done two things on this graph right here. The original graph was, as you may have on your paper, looks like this, and then this slope here. What I did on this graph was show you what it looks like just to do this vertical stretch, because a lot of people were confused about that. So the orange is just 2 times f of x. And then when you get over here, 2 times f of x minus 3 just means you're going to take this and shift it down 3 units. So that's what you end up with over here. We'll look at that in a second. But look at this, just the vertical stretch. When you multiply f of x by 2, you are literally multiplying all the y coordinates of every point on that function by 2. So the y coordinate there is 3. When you multiply it by 2, you get 6. All right? 4 goes to 8. 6 goes to 12, etc. All the y coordinates are now doubled, so you get your slopes are steeper. Okay, this used to have a slope of 1, now it's a slope of 2. This used to have a slope of -1/2, and now it's a slope of -1. So everything gets steeper, scaled upwards by this multiplying by +2. If I multiplied it by 1/2, then things would go the other direction. I would be multiplying that 3 by 1/2, and that would give me 1.5. I'd multiply the 6 by 1/2, and it'd give me 3. So it kind of squashes things down when that multiplier is a number less than 1. If it's greater than 1, it stretches it upwards, okay? So when you take this orange graph and shift it down 3 units for this part to complete the whole transformation, this point ends up being moved right back down to where it started, kind of coincidentally, right there at 3. This point up at 12 moves down to +9, etc. So all of these different parts of this function get translated down 3 units, okay? So that's what it looks like on the test tomorrow. Well, there will be a problem like this, but rather than combine transformations into one statement like this, I'm going to break it up and have you do I think it's 3 transformations, but each of them will be just one kind of transformation. So in other words, there'll be a shift up or down of the original graph. There'll be a shift to the right or left of the original graph. There'll be a reflection across the x-axis of the original graph, and there'll be some kind of a stretch or compression of that original graph. So I guess that's 4. So you do 4 transformations, one at a time though, okay? And I'll give you a big, nice big clean graph to draw your sketches on, okay? So that's the test. So pretty much everything on this team test is going to be on the solo test. And there will be a couple of other things too. There will be a couple of problems about the equations of a circle. One of them will be, you'll get a graph, it'll show a graph of a circle, and ask you to write the equation. All right, so if you remember, our center radius form is always this x minus h squared plus y minus k squared equals r squared. That's this, oops, that's a 2. That's the structure that we're trying to use to express the equation for a circle. So you got to identify the center. So the center here is 6, -1, all right? So the equation then is simply x minus 6 squared plus y minus -1, but y minus -1 would be y plus 1 squared, and then that equals the radius squared. So look at it again. What's the radius? From here to there is 3. So yeah, you can see on the graph that the radius of the circle is 3. So r squared then would just be 9, and you're done. So that's all you had to do. You'll have to see another problem where I ask you to write the equation of a circle given just a description of the center, coordinates, and the radius. That might even be easier. You just, you're going to have x plus 3 squared and plus y minus 12 squared equals, and the radius squared would be 49 in this case. Okay? There is one more problem that I just now remembered as I'm making this video about a circle, and we talked about it in first period today. I'm going to ask you to find the y-intercepts of a circle. So this one doesn't have any y-intercepts, so let me pretend that this circle now has a radius of, let's say, 3, 6, 7. Okay, so I've got a bigger circle now going around that point. I probably won't really try to draw the whole thing, but you can see if I was to draw a circle with a radius of 7, that it would cross somewhere up here and somewhere down there. So the question is, what's that y-intercept? What are those y-intercepts actually? There's 2 of them. So just like you would always find the y-intercept of a graph, you would put in 0 for x. So let's just do that. 0 minus 6 squared plus our y plus 1 squared equals 9, and we're going to solve it for y. You'll see that this is actually pretty easy. So that gives me 36, right? So I'm going to subtract 36 from both sides. Let's see, what is 9 minus 36? Boy, that's a tough one without a calculator, isn't it? I think it's negative 25. Is that right? Or, no, it's negative 27. Whew. All right, so negative 27. Okay. Well, this looks weird, huh? Why is something squared equals negative 27? What did I do wrong? Did I do this right? Let's see. 3, 6, 7. I got my... Oh, because it's no longer 9. Duh. It's going to be... Now I'm talking about a circle, same center, but different radius. I got to change this. Wow, that was close. So 49 is now my new equation, right, of the circle with a radius of 7. So 49, sorry, minus 36. What's that? Isn't that 13? Yeah, it's 13. Let's erase that. So we got 13 here. Positive 13. Whew. That was weird having a negative number there. That was kind of freaking me out for a second. So anyway, I'm going to solve it for y. So I'm going to take the square root of both sides. Easy, right? Plus or minus root 13. And subtract the 1. So there's my 2 y-intercepts. Negative 1 plus or minus square root of 13. Okay, that's a 1 right there. All righty? All right, that's good. That was a long video. Hope you hung in there. Hope you're doing okay. Good luck tomorrow. Have a great day. Bye.